Okay, so let's understand some basic properties like stress, strain. So first of all, stress. Stress, the set of external force acting on a body. Common loads are tension and compression. Stress is something like external force that acting on the body on the particular axis or particular dimensions. Like on a surface roof that is a plane surface roof, the stress is applied uh, to the one of the point and directly perpendicular to the uh, area vector of the surface. So it is a ratio of external force applied on the body to the cross section area of the body. So the ratio of there is a formula like stress is equal to applied force upon cross section of area. It is a formula for the stress where P is the load or force. P is we can call it a load, and we can call it a area, and and SI unit having the Newton upon meter square. So for mechanical component, generally unit of stress is Newton per mm square. Generally we use Newton per mm square, but when we talk about the SI units, the Newton per meter square we use that. There are some converters there are here. 1 kilo equal to 10 to power 3, 1 mega equal to 10 to power 6. They are general, like we learn in a 10th, 12th, and 11th. Types of stress: direct stress, indirect stress. Normal stress, shear stress. Indirect stress, we have a normal stress and a shear stress. And indirect stress, bending stress and torsional stress. Now we talk about the strains. It is the ratio of change in length to the original length. The ratio of change in length, that diversion in length when we apply the force or in external force on the body, when there is something change in the length in the dimension of the body. So the ratio of change in length upon original length is called a strain. Uh, it is a unitless quantity. It do not have any unit. So next one is a Hooke's law. Hooke's law is a within a elastic limit. Uh, let's understand within an elastic limit, stress is directly proportional to strain. That is called as Hooke's law. Hooke's law states that stress is directly proportional to the strain within an elastic limit. Elastic limits means the body which perform which we can elastic the limit. After that limit, we can't stress and it can't regain its original position. Means misunderstand rubber. When we stress a rubber, uh, uh, it has something limit to stress. After that stressing, it can't regain its original position. You know that like where E equal to modulus of elasticity or Young's modulus. We call E as a modulus of elasticity. E is equal to sigma upon means stress upon strain. The SI unit of E is Newton per mm square, Newton per meter square. The SI unit we're talking about the SI when we talk about the generally we use the normal the Newton per mm square. Then we then we derive the formula for the modulus of elasticity, that is sigma upon strains, that is P upon A upon delta L upon L. So E equal to PL upon AE. That is P is the we can say force, L is length, actual length, A is the um, uh, is the area of the surface, and E is the modulus of elasticity. There we get the uh, change in length formula. By using this equation, we can calculate the change in length. That is deformation. So next, understand linear strain. Hmm? Uh, Increase the positive and decrease negative. So linear change. Linear strain is the change in length divided by original length. Strain is we generally called strain is a change in dimension of original dimension. So dimension can be length, can be volume, can be something like that, surface, etc., etc. Diameter, yeah. So linear strain is delta L upon L, means change in length upon original length, and lateral strength means change in diameter upon original diameter, delta D upon D. We use here the negative sign because the change is a decrease in diameter. We get the decrease in diameter, so generally we use the decrease to the negative and increase to the positive.